In this video, I'm going to talk about pricing a stock using the dividend discount model. We're going to go through some of the theory, and it's really important that you understand the theory at a deeper level now that you've already had this in previous classes. The cardinal rule here is the value of any financial asset is the present value of the expected future cash flows. This means we need to estimate the size, timing, and risk of the cash flows. Well, in this particular model, we're starting simple. We're saying the timing is annual, so the dividend comes every year. The dividend was just paid today. The next one will be paid exactly 1 year from today. That's not an accurate assumption, but it's where we're going to start. The risk of the cash flows is determined by the discount rate, or the discount rate is determined by the risk of the cash flows. The size of the cash flows, well, we're going to determine those by looking at the current dividend and estimating a growth rate. So the formula is going to look like this. The price, P, at time 0, that's today, is equal to the dividend next year, the future cash flows, right? So the dividend next year divided by 1 plus K, and that's going to be to the first power. K is the discount rate, plus the dividend the next year times 1 plus K squared, plus the dividend the year after that, dividend in year 3, 1 plus K cubed. And the problem is this goes on out forever because theoretically the stock is going to pay dividends forever. So what can we do to make this a little simpler? We're going to make an assumption. The price today is equal to the dividend next year. We got that divided by 1 plus K. Well, what's the dividend in year 2? Let's say the dividend in year 2 is the dividend at year 1 times 1 plus G. That comes from future value equals present value 1 plus R to the T. So we're just going up 1 year at some growth rate. It's going to be divided by 1 plus K squared. So the dividend at year 3 is the dividend at year 1 times 1 plus G, and it goes 2 years, so that's squared, divided by 1 plus K cubed. I'm going to do one more because this goes out forever. Might as well stop at the next one here. The dividend at year 4 is the dividend at year 1 times 1 plus G to the third power, and I want the present value of that, so divide by 1 plus K to the fourth, and it goes on out forever. So how can we make this a little simpler? Well, somebody's already figured out a way to make the algebra look a little bit better and make a little shortcut to this. We'll multiply both sides times 1 plus G over 1 plus G, times 1 plus K over 1 plus G. So if I do it to this side of the equation, I have to do it to this side of the equation. 1 plus K over 1 plus G. So what's that going to look like? Well, 1 plus K divided by 1 plus G times P0. That equals, so if I take this 1 plus K, the one on the bottom goes away, so I have D1, and I keep the 1 plus G. And what about the second one here? This D1 times 1 plus G, that goes away. 1 plus K, that's on the first, so I have D1 over 1 plus K. So this is just algebra you've done before, maybe forgotten. D1 times 1 plus G squared divided by 1 plus G, that makes that to the first. It's going to make this to the second. It says D1 times 1 plus G over 1 plus K. And it's going to be to the second. Plus D1 times 1 plus G squared over 1 plus K cubed. And that goes on forever. I'm going to stop right there. I think that's a good enough place to stop. And what I'm going to do is I'm going to say, well, if I took 1 plus K, and I don't expect you to figure this out. This is what somebody did a long time ago. I just want you to know where the formula comes from so it doesn't look magical. But take this equation, call it equation 2, call this equation 1. Say equation 2 minus equation 1, so this minus P0, that's equal to, so if I take all of this stuff and subtract all of this stuff, or actually all of this, what am I left with? Well, the D1 over 1 plus G, here's a D1 over 1 plus K, there's a D1, right here, there's a D1 over 1 plus K. So those go away. D1 times 1 plus G over 1 plus K squared, that's the same as that, that goes away. D1 times 1 plus G squared It's the same thing as this over 1 plus k cubed. That goes away. So basically all this goes away and I'm left with just this. Well, can I make that simpler? Well, that's P0 times 1 plus k over 1 plus g minus 1 is equal to d1 over 1 plus g. We make that simpler. So I'll come over here and do that. P0 times, let's put 1 plus g in the denominator. So if 1 plus g is in the denominator, that's 1 plus k minus 1 plus g. That's the same thing as 1 plus k over 1 plus g minus 1. It's equal to d1 over 1 plus g. And then to make that a little simpler, P0 times k minus g over 1 plus g is equal to d1 over 1 plus g. And let's go with a slightly different color to give the answer here. That breaks down to P0 is equal to d1 over k minus g. So I don't really care if you get all of this algebra in here, if you just thought that was blah, blah, blah. The important thing is this. We know the timing is annual and starts next year. Right? Starts next year. So if I do that, and if I have constant growth, if this growth rate is constant, then the present value of all the future dividends breaks down to this formula. Which I can do one generalization of this. I can say the price in any year, in year n, is equal to, well, when did the dividends start? They started the next year. So the price in any year is equal to the dividend the next year divided by k minus g, as long as g never changes. So with all that background, now we're ready to do a couple of examples.